Good morning, ladies and gentlemen. Do this now. A 15 ohm and 30 ohm bulb are wired in parallel across a 30 volt battery. What is the equivalent resistance of the circuit and how much current flows through the battery?
Start with a diagram. So
We got
pause this, see what you can do. Take a look at your notes from yesterday.
do you draw them like this, or do
Yes,
you
I
do
do.
circles? Okay.
Yeah, I do.
Okay, so we said we have a 15 ohm. I'm just gonna use watercolor. And then a 30 ohm. And the battery has 3 volts.
Yeah. Now she's using the symbol for resistor, but a bulb is a resistor.
Oh, it's a bulb. I'm sorry.
Technically, it's okay.
Yeah, technically. But if you, oh shoot, it is a bulb. So you could make it like this. Like that.
Yeah.
Bada boom.
Yeah, that's more correct.
Okay, so what is the equivalent resistance of the circuit?
So in other words, what one resistor could you have
in place?
That would, so just draw an equivalent circuit right here next to it, just with one.
So in other words, we
one
want
resistor.
I keep doing
Now do a resistor this time because the battery doesn't know what it is.
Okay, so we want to know, what is this resistance right here?
Yep.
And this are the same thing.
The equivalent resistance. That's
okay.
right.
So how do we figure this out? We use this equation, right?
Yep.
So we've got 15 and 30. So 1 over the equivalent resistance equals 1 over 15 ohms plus 1 over 30 ohms. And Miss Moore's calculator is
I don't
over
see it.
other. It's in the wrong spot. Okay, so what was that trick, that button that we push?
It's the x to the negative 1 button.
X to the negative 1 plus 30 x to the negative 1, and we get our answer. Are we done yet?
0.1 is not the answer.
Nope.
You have to hit the x to the negative 1 again.
I get 10.
10 ohms. Okay. And you have an expectation of what the answer should be because it should be less than either of the resistances that are already there because it's a parallel circuit.
Yeah, that's a really great point there, okay? So, that's that first one. How much current flows through the battery?
3 volts.
Okay, well.
Now put an ammeter. Why don't you put an ammeter in that circuit right there? There you go.
Could I put it over here?
It doesn't matter which side you put it on.
Doesn't matter. Okay, so current is going to be the voltage over the resistance, yes?
Yes, ma'am.
Okay, so my voltage is 3 volts, my resistance is 10 ohms. That's going to be 0.3 amps, yeah?
0.3 amperes.
Bada boom. Okay.
See how simple this stuff is?
This is making sense?
Yeah, I hope so.
Yes, Miss Moore. Making all the sense in the world. Okay, so what causes, Felicity's coming on. Okay, what causes current to flow in any circuit?
You got wires, you got bulbs, you got batteries. What is required to make the current flow?
Well, you need an energy source, right? So
you need that's your battery, and you have to have a complete circuit. So an energy source, and there can't be any breaks. There has to be a continuous path for current to follow.
If you don't have a battery, then current will not be flowing. Okay, if the battery's chemical reaction works to maintain 1.5 volts, what determines the current flowing through the battery? What determines the current? Well,
it's where do those wires go?
Yeah, where do they go? So it all comes down to resistance.
Yeah.
Okay, when we talk about, when we ask that question of, how much current is flowing through it, it comes down to resistance.
If there's less resistance, more current flows. And if there's more resistance, more current flows. So it's kind of like this I is equal to V over R. More resistance, since it's an inverse function, it's on the bottom of the fraction, less current. Less resistance, more current. That's right.
Okay, challenge. Okay, so, wait, you okay?
Yeah, I'm fine.
Okay, so challenge, you're gonna need 2 batteries, 2 bulbs, and 5 wires, okay? And our goal is going to be to make a circuit that lights both bulbs, and should I go to the next one too, or just?
Yep,
And when you unscrew one bulb, they both go out. Draw a diagram.
This looks like a bunch of spaghetti here.
Okay, all right, so what we got here? So we've got our batteries here, We've got our two of these guys here. I'm just gonna go ahead and clip. So if we want them to both go out, if I unclipped, which kind of circuit should this be? I don't have to use all 5, do I?
You do not.
Okay. All right, so let's just go ahead and clip this up here. And actually, pause this for a second. I linked in a FET simulation to this assignment. And what I want you guys to do is before, I'm gonna stop right here. Okay, go ahead and go to that FET simulation and try and do this yourself.
Okay. Give it a shot.
Okay, so now that you are back and you have given it a shot.
So
okay.
if you unscrew one bulb and they both go out, that means that the flow of electrons, the current. Okay, when this happens, okay.
What were you gonna say, Boykin?
Oh, I thought it wasn't lighting up. So we have both of them. All right, so I'm gonna reach in and unscrew this one.
Oops, sorry, I just dropped it. Ah.
The other one goes out.
Yeah,
Can you see that? On, off. And why is that?
Well, it's in series, right? There's one path for the current to flow.
Only one
and when
path.
you break that path, the current stops flowing.
All bets are off. That's right.
All bets are off. Okay. All right, so let's see. So should we do a diagram? They know how to draw that diagram.
Yeah, just draw a series diagram with one bulb after the other.
Okay, so make another circuit that lights both bulbs, and when you unscrew one bulb, the other stays lit.
And go to the FET simulator and put in wires, bulbs, batteries, and see if you can do this.
Okay.
Meanwhile, we're going to give it a shot.
Meanwhile, okay, so it's like V for Valerie. The important stuff, right? Okay. All right, so here we go. Oh, thank you.
All right. I noticed these bulbs are much brighter.
They're
this
a
time.
lot brighter.
So if I unscrew and this goes out, the other one stays lit. And why is that?
Well, you've got more than one path for the current to flow through, right? And so, although this path is being broken, this one's not, and the current can still go through it.
And what kind of circuit is that?
This is a parallel circuit.
Parallel circuit.
You guys do that, okay?
Simple.
Okay, so, oh, right there. Now, let's take a look at our 1500 watt space heater.
There's a little heater.
And he is plugged into an 120 volt outlet. What can we know?
Well, watts are the units of watt.
The units of power.
Okay. And volts are the units of what?
Volts are the units for the electrical potential difference.
Okay.
So we know those two things.
All right. So what has power and electrical potential difference?
Power, electrical potential difference. Well, current does, right?
Yeah.
You guys see how I did that, right? Those two things.
Yeah.
Okay.
So we could find out the current.
We could find out the current.
So if we had the current and the power and the voltage, what else could we understand?
Well, if we have the voltage and the current, we can figure out the
resistance of the heater. That's right.
Anything else?
Well, what if you had that heater plugged in for, say, 10 minutes?
So you could know the...
What is power anyway?
So power is... so we've got current, which is charge over time, right?
Yeah.
And then we've got voltage, which is
joules per coulomb. Yeah.
Is that right? Yeah. Work over charge. Okay. These cancel.
Joules over, that's energy over time. That's joules per second.
That's, Oh, we know this. This is, no, never. I was thinking about the staircase.
It's a watt.
Think about the staircase again, yeah. So we've got joules per, why did I put time?
No, time is good.
It's seconds.
Joules per second.
Yeah, joules per second, yeah. So what was your question? What else?
If it was on for 10 minutes, what could we know?
We could figure out the power as well.
Well, if we've got the power, we could figure out the energy that it's converting.
Yeah, because you multiply the time over here. So if it was on for 10 minutes, you multiply that, you get that
into... It'd be 10 times 60, that'd be 6,000. 10 times 60 is...
6,000?
I think so.
Or 600. You guys do the math.
10 times 60 is 600.
It's 600.
It's 600. I'm
times
sorry.
Whatever your power is, and that gives you your joules or your how much energy output you
So
have.
that'd be 600 times 1500. That'd
Oh, yeah, we
be
have it in 1500 watts.
1500 watts
600
times 1500. 36 be
900,000.
900,000 joules. So
That's a
these
lot.
things eat up a lot of energy.
Doing all the work to keep us more warm.
That's
Oh
right.
yeah.
That's right.
Okay, so are we good there? We covered everything.
We're good, yeah.
That's all. Okay, so key terms that we have covered thus far. We've talked about power. We've talked about potential difference, voltage, current, resistance.
And you should know what each of these terms mean and how to use them in different situations.
Yeah, series versus parallel. That's what we've talked about so far.
Yeah.
Okay, so which variable describes how bright a light bulb is? Well, I'm gonna say it's power,
It's
right?
power.
Right. So because this time current times the voltage will give me the power.
Yeah.
More current, more power there.
And one way of looking at this, volts are joules per coulomb.
Mm-hmm.
This is coulombs per second. This is volts per ampere. And this is joules per second. So this is how much energy.
Mm-hmm. How many joules per second? Yeah. When there's any questions about, what the rate of something too as well, that is power.
Yeah.
Okay, I think you guys had one on the homework last night. Okay, so
challenge.
Here's your challenge question. This is your homework for today. So you are going to design a circuit using a 3 to 5 ohm bulb.
3 5-ohm bulbs.
3 5 ohm bulbs, where if one bulb is unscrewed, all go out, and if another bulb is unscrewed, the others stay lit.
Yeah, what is that going to look like? So you could use that PhET simulation, yes?
Yeah, you guys are going to be using...
Try to figure it out with a piece of paper and then try different things with your PhET simulation.
Yeah, let me pull it up here. So I actually, let me see. I don't know if you use the lab or the intro. I think when I was playing, I used the intro. And you can, you've got your resistors here. And I believe you can actually you can figure out you can change the value here.
Yeah.
You get to play. And I think with the lab as well, okay, values, I know you can change this somehow. I'm just not taking enough time right now to figure it out. Tap the circuit element to edit. There you go. Okay. All right, so go ahead and play.
Notice it has electrons or conventional. So the electrons flow out of the positive, out of the negative into the positive, and then there's conventional current which flows the other way that assumes a positive charge carrier. See, we're not making this crap up.
No, we're not making it up.
And it is crap. Okay.
All right, you guys, so play with that, and you know what? You've got one more thing for homework. It's this right here.
Well, yeah.
Right. We want them to do this.
Homework, classwork.
Oh well, yeah. Homework. Okay, so if you connect it, I don't need to read it. You guys are gonna work on this for your homework tonight once the video is finished.
And do you guys ever collaborate with each other? Is that possible to do? Can you talk to other students?
I know some people. I know. Marina and Paolo work together sometimes.
Yeah, do that. That is not cheating. Ba-boom.
Okay.